probably all the seats are taken. So I guess the AI, large language models and machine learning is a really, really popular topic. So please welcome Jeroen. He will be giving us talk about the machine learning ops. And are you ready for them? So please welcome Jeroen.
Yeah, thanks everyone. So, are you ready for MLOps? So today we're going to talk about that. And before we start, I'm actually curious because I see a room full of people. Who has actually used MLOps before, either personally or professionally? So I want a hands up if you have used MLOps before. All right, yeah, so I see some 10 hands, and that is really awesome because then that allows us to investigate this together. So there's actually some new information in here, so that's very good. So first about myself, I'm Jeroen Overschie. I'm a machine learning engineer at Xibia Data, and we are a global consultancy that helps companies become better in tech. And specifically, a machine learning engineer, we help companies bring their machine learning solutions into production. And today I'm here in Bratislava together with my colleague who's here in the audience, Ike, and we are very happy to be here in Bratislava and to be invited to PyCon. And I must say it's up to now a very beautiful city, so that is really great. So the title is Are You Ready for MLOps? And then first I want to ask, okay, what does it mean to be ready? So what it means to be ready is that we want to know what is the right timing for MLOps, what even is MLOps, and why are you using MLOps? So really to answer these questions, then we need some more information about that. And if we look at this illustration, this house, what can you see there? So you can see actually at the top there's a quite beautiful house. It has some nice windows, but it doesn't have a very good foundation. So the foundation, it's a bit destroyed. And yeah, we know you need a good foundation before you start building a beautiful house. So that's also what we're going to discover together. Okay, so in what order should we build so we can build a beautiful and nice and sturdy house? So before we do that, let's first take a look. So what did MLOps promise us? What even is this MLOps thing about? So what is the MLOps promise? So we're first going to look at the hype cycle. So you might know the hype cycle. So this describes, okay, how do new technologies come to the market? So at the left bottom, you can see there's a technology trigger. So something triggers a technology, and then the visibility goes up, and everyone gets really excited until we are at a peak, the peak of inflated expectations. And so there, once everyone is really excited, and then actually this excitement drops a bit because you have some reality check, or you discover, okay, maybe this is actually a bit more difficult than we initially thought. So the excitement drops until you're in a trough of disillusionment, and then if the technology survives, then again it goes up. So there's a slope of alignment, and then a plateau of productivity. So for example, you can also see technologies like large language models with the launch of ChatGPT really go through the cycle where we go to a peak and then it gradually starts becoming more productive and developing from there. So where's MLOps in this hype cycle? So if you ask some people, you might say, okay, we had just had this entire peak and now we're actually just coming down this peak. But if you ask some others, and if you also ask me, I can say, okay, we are actually on the way of really becoming more mature. MLOps is becoming more mature and we're becoming more productive here. So there also, we can ask ourselves, okay, then what indeed does this entail? So we just are becoming more mature, and then what does it mean? So what is this MLOps thing? So if we develop machine learning models, there's a lot of things that we need to think about. So in the middle here, you can see ML model. So from the machine learning model, we develop it. On the left side, maybe you do some feature engineering. There is pre-processing. You also need to do some configuration there. if at some point you start scaling it up, you need to orchestrate also your machine learning model and operations. You might add monitoring, scheduling. You need to serve the model maybe as an API to do predictions with your model. Data extraction as well. So these are all components that come into play when you're developing a machine learning product. And if we map all these different elements to some specific MLOps characteristics, then we might map them as such. So, for example, experiment tracking, which is an important feature of MLOps. That could be data set versioning. If you have a model registry to store models, then you could also do model versioning. You might have an ML pipeline, then adding CI/CD to further automate things, and adding monitoring. So these are all very important MLOps elements, and I want to zoom in more into each of them. So if we take a look, okay, so experiment tracking, what is this about? So on the left, you can see a screenshot of a popular open source tool, which is called MLflow. And MLflow allows you to log specific things that you want to log when you're developing a machine learning product. So, for example, each time you train your model, you want to log metrics about your model. What was the accuracy for the training set, for the testing set, maybe a validation set. And all this information you want to keep together in one place. So you can see MLflow as a database, but then specific for machine learning use cases. And here, you also get a nice dashboard. And so there we want to keep track of our experience. So if you run one experiment, and then that is successful, you need to know what was the configuration that made this experiment successful, so you don't lose it. So there are data set versioning. So this really goes hand in hand with experiment tracking, where if you track an experiment and then you loaded in some data and you trained the model and you had some great performance, but then you don't know, okay, which data did we train on? And then, in a way, the result is also lost because you cannot reproduce it. Maybe you go to your manager and then you're really happy, like, okay, we just trained our model, it has good performance. But then he's like, okay, nice, show me again. And they run it again, and it's like, but now the performance is worse because maybe you train on different data. You didn't keep track exactly which data did we train our model on. So that we also want to do. And here we see a different interface. This is Azure Machine Learning. So that is a different tool running on Azure, where in red you can see input data sets. That allows you also to keep track of your data sets that you train your models with. So a model registry. So if each time we train a model, we safely store it in the registry, we also need a specific database for that. So that allows us to keep track of the artifacts and the specifics that we need for storing a model. For example, PyTorch models, TensorFlow models, scikit-learn models. And that we can store in the model registry. And that also allows us to version our model. So we can create different versions for a model. And for example, we can also create a tag. Okay, this is our model that is in staging phase. This is the model that is in production phase. And that we can do in the model registry using model version. And then if we start building out, perhaps you want to chain different elements together of your machine learning project, and you want to create a pipeline, a machine learning pipeline. And here you can see a screenshot from yet another tool. This is running on AWS, and that offers another service which is called SageMaker, and there you can create a nice chain of elements together to form a pipeline. So maybe you train the model and then you evaluate it, and such you can get a pipeline. And CI/CD, which is at core for doing many automation. So here CI/CD, we can use it to deploy something. So for example, whenever you wrote some new code and then you want to deploy that code such that maybe the next morning a schedule is triggered and a new model is trained using your new code. And lastly, monitoring. So here you can see a screenshot. This is from a service on Azure that allows us to nicely visualize some metrics here. For example, the latency that we experience when we visit our prediction server, which is very important for users that use your model. For example, you go to a website and that live tries to interact with your model through an API, and then the performance is really slow. That is not what you want, so you want to keep track of that. You want to monitor that. And in the past screenshots, you could actually see I was showing different services. So to summarize that, we can also see cloud providers. They were really playing into this MLOps hype. So they really started building quite quickly also their own MLOps platforms. So Microsoft offers on their Azure platform Azure Machine Learning. Google offers Vertex AI. Amazon offers Amazon SageMaker. And even Databricks is doing more things with MLOps, providing also experiment tracking. So all the major clouds now also have solutions for this, for MLOps. So if we have all these features, then what is actually this promise? So what is MLOps promise to be able to do for us? So one main thing is productionization. So we want to go out of this experiment phase and really do proper machine learning, and we really want to use it in production, maybe at the core of your company. And so there we need some things also. So automated quality checks, and that allows us also to develop faster if we automate these checks. Maybe we do automated releases, and that also allows us to deploy faster. And we want better monitoring. And all in all, we want more reliable software products, and specifically more reliable machine learning software products. So this is what MLOps is promised us, that we should be able to do all these things. But so where do all these things come from? So we have all these promises and all these techniques, but where does it actually come from? So we actually go back to the hype cycle. And we saw this image. We put MLOps on the hype cycle. So we can see, okay, it's just getting productive now. But there's also this DevOps thing. So where's DevOps? You might have heard of DevOps. It's been around for a little while. And DevOps is like a lot more mature even. It's been around for a little while. And it's further down in the plateau of productivity. So we can see DevOps on the right side. So actually this is maybe even part of an ops hype, because we had MLOps, but maybe first there was DevOps. And then there was an ops hype. So all of a sudden, all sorts of different areas started getting interested in doing different combinations. So SecOps, security ops. If you combine it, DevSecOps. Or data ops, and there's even leg ops, legal ops. And we had the talk just before me, which was talking about large language models, LLM ops. So you can put a new technique, you put ops after it, and then you try to combine both worlds to get the best of both worlds. So this was really a hype. But DevOps, that already existed for a long while, right? So if we take DevOps and MLOps, and we look at Google Trends, so how much do people search on Google for these terms? In red, DevOps. In blue, MLOps. We can see, okay, DevOps already since a long while ago, so 14 years ago, it started really picking up more interest. And if you look really, really closely at the bottom right in blue, there's MLOps. It's much more recent. So DevOps has much more time to mature, and it was there a longer time. And then MLOps just started picking up. And I do have to note, of course, the scopes of these techniques are also different. So it is, in a way, comparing pears and apples, but we can see, okay, when did it start picking up? So DevOps started picking up a lot earlier. So indeed, okay, since 2007, DevOps has been around, and it tries to bring together the roles of development and operations, dev and ops. And what are the key principles for that? well, the key principles are automation. There is also collaboration and communication, which is an important part of DevOps. There is continuously improving, and also the focus on user needs. So this really tries to tackle when before we had more traditional ways of developing software, and we try to make it more iterative, more focused on the user, really try to collaborate with this development world and this operations world. So we stay tighter together, so there's not as much a handover. So there we can visualize it. This, I think, is a beautiful visualization. So where we can see at the bottom left of this circle, there is build. So first, if we build something, then we test it, we can deploy it, but then we also have to operate and observe. Then we get feedback, so we continuously always gather feedback. And then again, with this feedback, we discover, okay, can we again build new things? And then we plan, and then we build again. So there's really a reason why this is a continuous cycle. So at all times, we try to gather again the feedback to make our product always better. And so you might have also seen this pyramid. So for data science products, there exists this pyramid. And what this pyramid tries to illustrate is, okay, what is the hierarchy of things? So what should be in place before we can move up in the pyramid? So all the way at the top of the pyramid, there's AI and deep learning. So, and this was, of course, also a very popular subject at some time, like deep learning. And everyone was super excited about deep learning. And all companies, everyone wanted to also do something with deep learning. But it's really important to take into account the prerequisites before you can do deep learning. So if you're a company, and then, you're just at the beginning of gathering your data from all your processes, like logging everything in a nice way, and putting everything in a neat database, making sure your data is ready. That is a step before you can even think about doing deep learning. So this really illustrates, okay, what is the order in which you should do things, like what should already be the foundation before we can start moving up. And this, let's see if we can also build such a pyramid for DevOps and MLOps. So how can we build up things in a logical order in the DevOps and the MLOps world? So if we have a source code repo, then we probably want to check it into Git to get version control. You want to do some config management, so that's, for example, environment variables, and really be able to configure your app for different users, all API keys and such things. Then on top of that, so we have it in Git, we can start thinking about continuous integration, CI, then its counterpart, CD, CI/CD, continuous deployment. And then on top of CI/CD, then we can put some other things. So there with CI, we can start thinking about adding some tests to our code, like automating that. There's then some philosophies that you might follow. TDD, BDD, test-driven development, behavior-driven development. Then if we have a solid test suite, we can also fine-tune that. Then there's linting, formatting, both for quality assurance. Okay, make sure our code is of a minimum level before we start deploying it somewhere. And then if we want to continuously deploy our code, if we have infrastructure as code, so your deployment is defined in code and it can be deployed somewhere. And then also containerization. So we can put that on top. And there we can also see a bit, okay, it does touch DevOps principles there. So CI/CD we could see is important DevOps principles. All this automation, which was one key principle of DevOps, that also plays a role here. But we're going to build our pyramid higher. So here we have infrastructure as code. So we can now continuously deploy our product, and then we can deploy it to the cloud. So we can deploy it to some cloud. And there also you can make a separation between your development environment or your production environment. And they also sometimes called DTAP if you add even more environments. And there we can build on top of that. So we are on the cloud, so we can use some cloud service for logging and monitoring. So we can publish all these logs and metrics to another service which is running centrally. And there we can also do this visualization, so that we also showed earlier this graph. Okay, what is the latency of your API? Then that is also desired if we start running in production. And then we have logging in place, monitoring in place, we're on the cloud, and then it's possible, okay, we can start thinking about adding experiment tracking. And there also the model versioning, so they should be familiar by now. Then dataset versioning as well. Because we're on the cloud, we can have a database, we can store our data all there. Then, for example, more advanced features, we didn't even mention them yet, like drift monitoring, the ML pipelines, they come familiar, maybe scheduling as well, and orchestration. And there you can see now at the bottom, we just have these DevOps principles, and we start building our pyramid higher. It's not exactly the shape of a pyramid, but we tried our best. And there we can see at the top, only there is more MLOps. So the blocks, they really build on top of each other, and there at the top, then it makes most sense. Okay, we do drift monitoring, and we do the experiment tracking, and the foundation is in place. So if we go back to this building that we saw before, with a beautiful top and a very broken bottom, then if we have DevOps at the bottom and MLOps, without a solid foundation, you cannot build a nice house on top. It's not solid. We cannot build a nice house. So we want to make a solid foundation. We want to make sure, okay, our DevOps is in place. We have everything in place that we can do nice things with MLOps and go even higher. So this is really where you need a solid foundation to build a nice house, add more features on top. Maybe you want to create a bigger balcony. You can create all sorts of bells and whistles and extend it more, only given that you have a solid foundation. All right, so we saw DevOps. So we just dove into this world of DevOps. We saw, okay, how does it relate to also MLOps? But then what is the MLOps twist? So what is now more specific about MLOps, what even makes it different? So we saw these two circles, but MLOps also has its own version for that, which is then really inspired also by this first circle. So this is where we ideate and we experiment, develop and operate, and also, again, in a continuous way. So where we really think about, okay, what kind of machine learning product do we want to build? And you build it, but you keep monitoring, okay, how much sense does it make? Is it operating in a good way? And then you can go back to experimentation to improve it even further. And also, we talked a lot about technology, and I talked about the different clouds and what elements of MLOps are important, but really that is actually not it. So the technology is an important part. We also want to emphasize the process and the people. So MLOps, it should be in the middle. So with the process, okay, it means in what way do we work together? So what kind of processes are in place? You have heard about agile, or in what way exactly are we working? How often do you release, and what kind of time spans do you work? And especially also the people. What kind of people are you putting in the same room together to collaborate? What kind of role do they have? Is it a data engineer, machine learning engineer, data scientist, platform engineer? Do we put them together, or are they in separate teams? And if we zoom into this people aspect, then if we develop a machine learning product, there might be two important parties. So the one is developing the machine learning product. So for example, data scientist, and they know a bit more about the domain. And on the right side, the machine learning operations. So that could be a team it could live in an entire different world. So for example, on the left-hand side, you use Python, maybe you experiment a bit in a notebook, and then you create a model out of it, and you have a machine learning model, and you give it to operations, and operations may be a different world. So that is in your company, a team, and that maybe it writes even in Java code, right? It uses different technologies. Their roles are also different. Maybe it's platform engineer, software engineer, and there's a different world. So maybe there can be a bit of tension there. Because between these different worlds, yeah, it can be quite hard. So yeah, here we want to build a bridge. So we want to really see, okay, can we bring development and operations closer together? And so there, if again on the left-hand side we have development and the right-hand operations. So yeah, we really want to span the teams such that they cover like both parts of the spectrum. So you might have an ML product team which really develops the model. Then we have an ML platform team and a data platform team which are really tightly collaborating together. And that is really a prerequisite for proper collaboration to make a machine learning product, which is really also part of MLOps. So okay, so when to consider MLOps? So what we just saw, all the principles, if we summarize them, we have the tools and tech. So tech, the people and skills, process and ops. So that is also part of the 3 circles that you saw. But then we also add data as an important prerequisite. Is your data in the correct format? Are you mature enough that your data is in the correct shape? And if you're more curious about the check marks, then contact me afterwards. We have some more details, but I don't want to bother you with all the details right now. And there, indeed, if we talk about MLOps, then I also want to give you some headers. Okay, if you want to know more, and there's a community for MLOps, what can you consider? So there's a worldwide MLOps community. I myself live in Amsterdam. Sometimes there's a meetup in Amsterdam that is really worldwide and also remote. There's a community for that. There's also in the Netherlands a city called Eindhoven, which is a very active data community. So that is meetup.com, which offers things. Yeah, we ourselves, we also have a blog and we offer trainings. And also we have a offering for creating MLOps platforms. So there's a lot of things to read and to discover, and a lot of meetings that you can go to, because the MLOps community, it is indeed very active. So if we go back to the main question, are you ready for MLOps? So if you are ready, tomorrow we have a tutorial at 10 o'clock together with my colleague, Ike, in room B. So if you feel ready, please do come join us during the tutorial. So in 3 hours, we're going really interactive, play around with MLOps, and then you can learn even more. So with that said, I would really like to thank everyone here.
Okay, so thanks for your talk. We have some questions, so we can start. I will read them for you. The data versioning for big data is not trivial topic. What solutions do you use in your company?
All right. So, the question it states that it's not easy to do, trivial. So there I can respond that I assume that if you have big data, maybe the concern is also about, okay, we don't want to, for example, copy the data, or how are we going to know, okay, we're using exactly this data. There are some things that we see in the industry is that if you make your data such that it's immutable, so that you can assure it never changes, maybe you can be smart and only just store references to your data. Instead of each time when you version the data, you create a copy. Maybe your data is so big that you don't want to copy over data and create a new version, but maybe you make your data such that it never changes. That is something that you can create a guarantee about, and you create a reference. That is something that we do see sometimes.
What do you think is missing in MLOps universe for it to be fully mature?
All right, that's another good question. Yeah, so I think over the last time it has become a lot more mature. But yeah, what we see at clients, so as a consultancy, is that we come at companies, there are data science teams, and I think still it's a slow process to make sure the correct capabilities are in these data science teams. So for example, often you see someone has a role, data scientist, and then some of the skills that they have is maybe they know a lot about the domain, and yeah, they know some about Python, and they yeah, for example, they experiment in Jupyter notebooks and things like that. But I think they're slowly, if companies realize, okay, we can really make a step in efficiency to educate the data scientist, and then educate them in getting the skills that they need to shape the code in such a way that they can go to production faster. So you're already with production in mind, you shape the code, and then the handover step is much smaller. And also there, I think it's also organizational. So I think these are slower processes, right? So if you have a company and you want to put the right people in the same room, you have to reorganize your company a bit. So maybe the teams are super separate. So you have a platform team and a data science team and a data team. You want to more mingle them together. Yeah, that's organizational change. So I think there's really a big step still that we can make in become more mature.
What is your view, the best tooling for MLOps currently available? There is an example, Azure DevOps, Azure ML, and ML Flow.
Okay. Yeah, there, to be honest, I don't want to be too opinionated here because as consultants, we work with all these technologies. Yeah, so personally, I think your consideration should be, do you want to go managed or do you want to deploy these services yourself? So you could, for example, deploy ML Flow yourself on the cloud. You stay more in control. And Azure Machine Learning, then it manages more for you. It does integrate with ML Flow. So yeah, I think your consideration here, like which tooling to use. Are you going to use a cloud or are you going to deploy everything yourself? Yeah, I could say my opinion there is when we help clients, and if you're not part of a really big company which has teams that can actually maintain everything that you build, then managed solutions, they could be a really good choice because you just have less to maintain. So yeah, I also like myself integrating with these solutions. Yeah, that is what I can say.
Okay, so from your experience, how much effort is needed to go from POC to the proper production with MLOps compared to building POC and experimenting and to be in production?
Yeah, so this is also a question that we get a lot from clients because they want to know, okay, you come help us with MLOps and what is the gain? And then we first try to do interviews. So hey, how much time did it cost you from when you start writing some code to actually deploying it? Maybe it's 1 year. And then we can see how we can help them with MLOps and put the right structure in place. So there's some initial effort. So maybe you spend some months in putting the right MLOps structure in place. And then we could see that the time decreased like drastically. So maybe you have an idea, you start working it out, and 1 year later something is in production. Yeah, then we can see it go to some months. Some couple months when you have an idea, start working it out, but you have the MLOps platform in place, so the right elements are in place, and then the time to production is much faster. So that is the ballpark that I could give. Yeah.
In my experience, people and existing processes are the biggest hurdle in the implementing proper MLOps principles. Any thoughts on how to approach this in corporate environment?
What was the last part, sorry?
So I think that the biggest struggle is to change people's minds and the processes in the corporate. So if you have any advice how to approach to change the corporate to, let's say, make people think differently or change the mind, or let's say accept what you have been talking about the whole presentation?
Yeah, yeah, okay. Yeah, so I think a key there is that it should be really clear why you are doing this. So if you just come to an organization and then you are explaining about restructuring the organization because it's better and because of MLOps, yeah, then they don't might want to accept what you're saying if you don't have a solid reasoning. Why is it better? So why is it better to put all these roles in one team, for example? Then you can really go with the argument of explaining, okay, why is MLOps beneficial there? Because if we have all the skills together in one team, and we can more efficiently develop the product, and then there's less of a handover. Especially the handover part, and you can really emphasize that. So I think there, it's not much of a technology argument, but really explaining, okay, how can this help us? And really focus on there, so that everyone is aligned first, and then you can start the realignment process, the restructuring process, which is usually quite hard. Yeah.
Is your source code independent from the MLOps tools?
Usually not. So usually we do integrate with some managed solution. So you saw on the different clouds, there's solutions on every cloud, Azure ML, SageMaker, Vertex AI. And there's the trade-off. If you want to stay agnostic, you're putting a lot more effort in staying agnostic. So if you integrate with that, you do choose. You make a choice, but you get a lot of convenience back. And then there are of course cases where a client demands, okay, we need to stay agnostic, or we even run on-premise. Yeah, then you can work out different things, but that's really the trade-off. Then you will spend more time spinning everything up. Yeah, but the short answer is usually not.
Will the slides be available? So I guess if you publish them somewhere, or
yeah, I can make them available. So there will also be a blog post about this, and then there they'll also be available. So I'm not sure how to reach this person, but they will be available also online.
So probably if they get you on LinkedIn or maybe some other social media.
Yeah.
Have you?
Yeah.
So you got LinkedIn, right?
Yeah.
So
like to this person, feel free to add me on LinkedIn, and then I can share the slides. Yeah.
Which tool would you recommend for storing datasets and models? AWS, S3, Minio, etc., etc. If it was supposed to be one tool, which it would be?
Yeah, it's really dependent on your use case as well. How big is your data? Do you need to access it in a distributed way? What type of data do you have? Is it more time series, tabular, structured, unstructured? Yeah, there's cloud solutions that they scale very well. They are built for scale. So whichever cloud you're on, you should think about these elements, right? What type of data do you have? And then a lot of cloud solutions, they are very scalable. So I cannot actually just give you one solution. Yeah.
I think we already touched about what is your favorite platform, MLOps, in the previous question, so I guess we can skip that. And the last question is, what is the most important question the data engineer need to ask the data scientist when working on the same product?
That's another interesting one. Yeah, so between the data engineer and the data scientist, you can sometimes see a handover because the data engineer could prepare the data for the data scientist. So there, I think it should be really a conversation about how do I best enable you with what data. So you could see sometimes the data engineering part, they ingest some ideas from the business and from data scientists, and then they make it perfect engineering-wise. But then you should not lose track of the main requirements, right? So what type of data do we need? Because it also changes over time. So that the conversation should be like, okay, how should we best enable you? What type of data do you need? Which columns in what format? And that should be iterative. So you should keep talking. It should not be just talk and then hand it over. Yeah.
Yeah, definitely. Conversation is really important. So yeah, thanks again for your talk. I guess we explored the topic really good, and I hope you liked it and people.
Thanks.